week 11. Please make sure that you get that done. And then also don't forget about your independent practices for this week. Your second one will be posted here after this class. So go ahead and keep answering the opener there. How are you feeling today? And how well do you feel like you understand systems of inequalities that we started talking about on Tuesday? Sorry, lost my train of thought on what the heck day it was. And we'll wait just a few more minutes to see if anybody else joins us here. And I will go ahead and let you guys in on a secret. We are finished with our unit. So everything that we've worked on since the beginning of the year has all been part of Unit 2. And we are going to be doing some review and preparing for our end of unit assessment that is coming up next week. So you guys kind of have some inside knowledge with that since you showed up to class today. Just looking at your all's responses here, and I will give you just a little bit more time. Again, forgive me for any typos or anything. Mr. Rucker, it looks like the scholar that we discussed earlier today, by the way, is not here. So I don't know how that will affect you working with that scholar. Sounds good to me. All right. No, 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 no. This one is not. We're going to have a few questions thrown in there for review, just to kind of see what you guys remember about some of our older stuff, just to kind of break it up. But we're still working with our systems of inequalities today. Thank you for asking. Yeah, go ahead. You have a week 11 quiz that covered everything before our systems of inequalities that we've started working with today. And then your unit 2 assessment that will be next week, that will cover anything we've talked about so far. And we'll do review for that as well next week. Okay. Yes, anything we've covered from linear equations to systems of equations to this new stuff, anything could be on that. Okay. So we'll talk about that more next week. And like I said, I kind of sprinkled a few review questions here in today's lesson just to see what you guys remembered about a few things. So I know how much time we need to spend in different areas. But today's focus is still going to be on those systems of inequalities. All right, and on this next slide here, if you didn't notice, it should have flipped over for you. Just kind of want to see where you're at with your stress level. If you participated in your Red Hawk Readiness Advisory lesson today, hopefully you talked about some strategies to help you cope with stress in your life, because unfortunately it's just something that we're not going to be able to live without. There will always be stressors in our lives. So just kind of wanted to get a check and see where you're at with your stress level today. And again, if you're not logged into our activity in Pear Deck today, that link is in the chat box. You can also go to joinpd.com and use the code at the very top right hand side of the screen to access that as well. All right, so for the sake of time, let's go ahead and keep on rocking here. So on your first question, we would like for you to place a point on this graph to show us where the feasible region is located. So we want to see what you remember from Monday, or excuse me, Tuesday. Sorry, I get my days all jumbled up. So place a point on your graph. Go ahead. As long as it's in the feasible region, it doesn't matter where it is. And they pop up really small on my end, so just give me a second to make sure I can see where you guys are plotting your points. Some of them are harder to see than others. Again, sorry about any typos. Just trying to make sure I get to everybody here. And if you have any questions on any of these slides where it's like you can draw on them and you can write on them, just put like a big question mark or a big star or something like that on it so that visually we can see that you need help and I can click on your thing and see what you wrote and see what you need. All right. So anything that you plotted that is inside of this kind of red bolded area that I've outlined, that's where the feasible region is located. Because remember, feasible means possible. So it's where all of our possible solutions are located. So if we look at this graph, there are two colors of shading. There's the blue shading and the red shading. So we have to look for where those two overlap. One of the tips that a scholar gave earlier is to look for the darkest part of the graph because when if you think about like painting or art, when you start layering different colors on top of each other, it usually gets darker and darker and darker. So the darkest part of the graph is typically where the feasible region is located because you're layering those colors on top of each other. All right, so this one's a multiple choice. Which region represents the feasible region? Give you a few more seconds there. All right, the correct response there, most of us got that is region C is the feasible region because that's where the inequalities shading overlap each other. That's the darkest section there of the graph. All right, here's another multiple choice. This time you're going to tell me which point on the graph or is a solution. So which of those 4 points that are marked is the solution? or is a solution, sorry, not the solution. Remember that tip that I shared from another scholar from earlier? The feasible region or the solutions are located on the graph where the shadings overlap, so it creates kind of the darkest part of the graph. So in this case, we're trying to look and see where the red and the green sections overlap each other. And the correct answer there is the point 5 comma 3. That is the point that is in kind of that greenish brown section where the red and the green are layered on top of each other. All right, here's one of our throwback questions for Throwback Thursday. Fill in the blank. The slope of the line y equals 5 minus 3x is. I know it's been a while since we've talked about this, so it's always good to stay fresh. Give you just a little bit more time on that. All right. So most of us were on the right track, but the slope of the line is the number in front of the x term. So in this example, it's going to be -3. Okay. So not just 3, but the minus is also attached to it. So it's -3 is the slope. Okay? The number in front of x in the equation is the slope. All right. So describe in words how someone could find the feasible region on this graph. And if you're not logged into our activity for today or you get kicked out or whatever, please make sure that you get back into the activity so that you can get the practice and the feedback that you need with this content to be successful. Thank you to those of you that have already responded. Still waiting on AJ, Mohammed, and Jordan. And again, there are a few of you that logged into the Teams meeting, but you're not actually logged into our activity. So please, please, please get logged into that activity before it's too late to both earn credit for participation and to make sure that you're getting the practice that you need and the feedback from us that you need to be successful on your assignments. All right. Oopsies. Hang on just a second, you guys. I apparently lost my connection. But anyway, the feasible region is where the green and the purple shadings overlap each other. It is the darkest area of the graph, all of those things that you guys referenced. All right, let's see if I'm back in action here yet. Okay, there we go. So go ahead and on that graph, plot a point that is a non-solution to the system of inequalities. Plot a point that is a non-solution. Yeah, go ahead. Yes, where the two lines intersect. Very good question. So if we place a point directly on top of that intersection point, it would still be a solution only because the two lines are solid lines. If either of those lines was a dashed line, that would not be a solution. So so if the green line was dashed instead of solid like it is now, we could not place a solution on top of the line anywhere along the line. So right now, if we wanted to include the place where the two lines intersect, it would still be a solution because they're both solid lines. But if either one of them was a dashed line, it would not be a solution where they actually intersect. Okay? All right, you're welcome. All right, so I just want to show you this really quickly. So the only point that is actually a solution that has been graphed here is this one right here, kind of towards the bottom right. That is that black point located right on top of the purple line because that is still in a double shaded area and it's on a solid line, kind of like what you were just asking about, Malia. So all of the other points on the graph besides that one black point right there on the purple line are correct. They are all non solutions. So remember, anything inside of that little area that I boxed in is a solution. Anything outside of that area is not a solution. All right, here's another throwback question for you. Which graph shows a system of equations with no solutions? All right, I'm glad we did this one. So remember that when we look at equations and we talk about the number of solutions that it has, what we're really talking about is how many times the two graphs are intersecting each other, or excuse me, the two lines are intersecting each other on the graph. So if we have no solutions, how many times should we see the graphs, to the two lines cross each other on the graph, and which picture shows that? All right, so the correct answer here is going to be graph B. Remember, if we have no solutions, that means the two lines never intersect each other or never cross over each other. And on graph C, we can see that the orange and the green line do cross over each other. And then on graph A, it appears to only be one line because remember, the two lines are actually stacked on top of each other. So graph A has infinite solutions, graph B has no solutions, and graph C would have one solution. All right. So Erica believes that 1 comma 5 is a solution to this system of inequalities. Which statement below is correct? All right. So the correct answer here is that 1 comma 5 is not in fact a solution because it's on a dashed line. Okay, so remember, just like what we were talking about earlier, it cannot be a solution if it's on a dashed line. Okay, remember, dashed lines are like holes in the ground. If you walked up to a hole in the ground, you would fall through it. You wouldn't be able to actually stand there. So, um, anytime you have a point on a dashed line, it is not a solution. All right. Which coordinate point listed below is not a solution? All right. Looks like everybody that was going to responded has. So the correct answer there is 3 comma 1 is not a solution because it's not in the feasible region. Also, if you look at the graph, it's also on a dashed line, which we just discussed cannot happen. We cannot have a solution on a dashed line. So this means it would not be possible, excuse me, got the hiccups, for us to spend 3 hours on the trampoline and 1 hour at the pool based on that graph. All right, here's a kind of throwback because it's still talking about inequalities. But which linear inequality matches the purple line and shading? Which one matches the purple line and the shading? All right. So the correct response here is going to be option number two, that second one. The reason for that is because the only difference between those two options is the type of symbol being used. So we're not testing your knowledge of whether the shading is on the right side of the line. We're testing your knowledge on what type of line should be graphed. So because the line is a solid line on the graph, that tells us that it has to have the little equal to line underneath the inequality symbol. Okay, so it's going to be option two because it's a solid line. All right, so on this graph here, place a point in the feasible region of this system of inequalities and write its coordinates. Now, for this graph, each line is counting by 5. Okay, so 5, 10, 15, 20, and so on. If you're having trouble knowing exactly what your coordinates are, just give it a shot and I will help you. Also, I'm very impressed. You all are giving me the most variety. A lot of my other classes gave me the exact same point over and over and over. Give you just a little bit more time there on that one. All right. Great job today, you guys. So we've got just two more things here to do. So for this slide here, you're going to give me your reflection. And I want you to think about two things. So with your red star, you're going to drag it to show me how much more you understand finding a solution to a system of inequalities after today's lesson. So less than before, same as before, or more than before. And then on your orange circle, you're going to drag that to show me how confident you are with finding a solution to a system of inequalities. So, how confident are you in finding a solution to a system of inequalities? And don't forget, you can put it anywhere along those pathways. So, if you, for example, are somewhere between the same and more, feel free to drag it anywhere along that spectrum. Okay? Just want to kind of see where you're at with your understanding compared to Monday or Tuesday's lesson and how you feel right now. Go ahead. Yeah, absolutely. Yes, absolutely. You can put both of your reflection, your star and your circle anywhere along that spectrum. It doesn't have to just be on top of one of those. All right. Looks like all of you have solidified your choices there. So in Google Classroom, you have another independent practice covering the same material so that you can get lots of practice with your systems of inequalities. It's due on Monday. And I just wanted to make sure to remind you to please, please, please reach out to us with questions via email, via Google Classroom, whatever. And we can schedule a time to get with you, especially on Fridays, to work with you one on one in order to help clarify whatever questions you have or misunderstandings you have or whatever. Okay. So make sure you get your independent practice 1 and 2 done. And if you haven't done your quiz yet from last week, please make sure that you get that done as well. And you are free to go. Have a great